So with our first example for this, I have 9n squared minus 3n minus 8 equals negative 10. So just like solving by factoring and solving with the quadratic formula, I do have to get everything set equal to 0, okay? So I'm going to end up having 9n squared minus 3n plus 2, and that equals 0. Now remember, all I have to do here is find the discriminant. I don't actually have to find out what the x-intercepts are. I just need to figure out the what the discriminant is, the number and type of solution, and how many x-intercepts we have. Okay. And so, so here, let's do our b squared minus 4ac. Okay, if you need to write out a equals 9, b equals negative 3, c equals 2, that's fine. You can go ahead and do that. So then what I end up getting when I calculate all of that, I get negative 63. Okay, so that means my discriminant is negative 63. Okay, I have to determine the number and type of solutions. So I do have two solutions, but they're imaginary. So that is the number 2 and the type of solution imaginary. So I have two imaginary solutions. Okay. And then the final piece is how many x-intercepts I have. I have no x-intercepts. Okay, 0 x-intercepts, nada, nothing, zilch, okay, because I have a negative discriminant, okay, because technically if I would go about solving this whole quadratic formula, I'd have, you know, my negative b plus or minus the square root of negative 63, so I'd have a complex number there, okay. Let's look at our second example here. I have 2x squared equals 10x plus 5. Oops, hello. Okay, so again, got to get it set equal to 0. So 2x squared minus 10x minus 5, that equals 0. So I'm going to do b squared minus 4ac. So I calculate all of that, and I get 140. Okay, so that is my discriminant. So my discriminant equals 140. Okay. So because it is greater than 0, I do have two real solutions. Therefore, because I have two real solutions, I will end up with 2 x-intercepts. So those are the 3 pieces of information that were asked of me. Okay, so that means technically, you know, on this graph, I don't know where it's going to hit it, but it will hit twice. On this other graph, because I had negative 63, again, I don't know where it'll go, but it will never cross that x-axis because I have 0 x-intercepts for the first one. But for this one with 2 x-intercepts, it does cross the x-axis twice. And I have one more example for you. 4k squared plus 5k plus 4 equals negative 3k. So again, got to get it all set equal to 0. So I get 4k squared plus 8k plus 4 equals 0. So again, b squared minus 4ac. Oh, that was really bad. You can't even see what I wrote there. 4ac. Oh, look at all those 4s. I love 4s. It is my favorite number. So when I do all that, when I calculate it, I end up getting 0. So the discriminant here is 0. So because my discriminant equals 0 on the nose, it is 0, I will end up with one real solution. Okay, therefore I will have one x-intercept. Okay, so if I would go about and actually solve this using quadratic formula or whatever, I would end up just getting one number. So you got to think back, it's kind of, you know, back like when you had, you know, x plus 5 times x plus 5 equals 0. Oh, well, you just got the same number, you know, both times, so you only had one solution. Okay, that would be a case where I had one x-intercept. So kind of like trying to link all of those things together, what we had discussed many, many moons ago in our lessons here. Okay, so it's kind of like I said, it's like as if you factored and you only got one solution for x. That means that you only had one x-intercept, okay? So that is this case. And that actually wraps up this video here.